So this hill that we're going down today, this is an 18-degree slope or a 32% grade, which means every 100 meters that we go forward, we go down 32 meters. Now there's really nothing to worry about. This bus has been designed for this trip exactly. So it has a special feature, which is called the transmission lockup. What this means is that if you go down this hill here, I press the button on my dash, which engages my transmission lockup. And this makes the bus go down the hill nice and slow. As we go down this hill here, a majority of the braking is being done by my engine. You can just hear I'm just tapping my brakes just a little bit, but a majority of the work is being done by the bus, so it's a very easy and a very safe trip down. There's really nothing to worry about here. Now, if we take a look at the glacier from here, you're going to notice there's a lot of dirt on the glacier. Now, a lot of the dirt that you see on the glacier is from the lateral moraines. The winds out here, they pick up a lot of dust that blow onto the glacier, which makes the glacier look very, very dirty over time. Alright guys, we're down the hill here. So the bus is going to jump here in just a moment. Can I get a yee-haw? Yeehaw! There we go, excellent. Alright. Now to the left-hand side here, just beside the bus, you're going to see what looks like a large pile of rocks. Now what this really is a huge piece of ice with a small layer of rock on top of it. So we only have about 1 meter of rock, which is sitting on top of 30 or 40 meters of ice. And the rock which is on top of this ice, it insulates the ice and it protects it from the warm sun. So take a look to your left-hand side and take a look back to the right. You'll notice this section on the left-hand side is higher up. That's because the ice which is underneath this rock is melting much slower. And this is because the rock, it insulates the ice from the sun, and this makes it melt much, much slower. Now the core of this section is made out of ice and it's covered in moraine rock. So this section of the glacier is called the ice core moraine. And you can find some of the oldest ice which is in this glacier, this section here. And as they move along, you are going to see some sections of ice which are exposed. Now in just a moment, we are going to drive through a large puddle of water here. So this puddle of water is what we like to call the tire wash. Now this is a man-made puddle. We purposely bring water through here so we can clean our tires before we go onto the glacier. And the reason why we do this is we don't want to get the glacier dirty. Any dirt we bring onto this glacier makes the glacier melt much faster. And this is because of something called the albedo effect. So snow and ice, they're very reflective surfaces. Snow and ice, they reflect around 70% of the light that hits it, and this means it's absorbing very little light, and this means it also absorbs very little heat. So snow and ice, because of this, they heat up very slowly. Now any dirt we bring onto the glacier won't reflect as much light as the ice, so it's going to absorb more light and therefore absorb more heat. So any dirt on the glacier heats up faster, and it makes the surrounding ice melt faster as well. So that's why we want to try and clean our tires before we go onto the glacier. We want to maintain the glacier and also maintain the roads. These roads are very, very sensitive. Now to our left-hand side here, you're going to see this big ridge of rock which goes down alongside the mountain. So this is a continuation of that lateral moraine. So this moraine here, it stretches for 5 kilometers or 3 miles in total. Now I mentioned a little bit earlier that the lateral moraine is collapsing. Now take a look at the moraine from this angle. You can see there's all these cracks and all these lines going down. So these cracks and lines, these are all rock slides that have been happening. Now back in 1843, the glacier was sitting way above the lateral moraine, and it was pushing all this rock off to the side into this huge mound. Now when the glacier was sitting way up there, it was supporting all this rock and holding it in place. But now that the glacier is melted down and disappeared, there's nothing to support the lateral moraine anymore, which is why it's beginning to collapse. Now as these rock slides come down, some of the rock will come down and begin to cover the glacier. And when it starts to cover the glacier, it begins to insulate the ice. And this is how that ice core moraine was formed. It was due to the rock coming down off the lateral moraine and beginning to cover the ice and beginning to insulate it. Now not many people know what the difference between a glacier and an ice field is. A glacier is simply a large moving piece of ice. So if it's big enough, made of ice, and it's moving, it's considered a glacier. Now an ice field, on the other hand, is a large area of land which is producing ice. So what happens in the ice field is when it snows in the ice field, the snow begins to pile up. Now once the snow has piled up high enough, the bottom layer of snow, it has extreme weight on it, the snow above it, and this extreme weight, it pressurizes that bottom layer of snow into glacial ice. So the ice out here is very, very dense. It takes over 100 meters of snow to make 1 meter of glacial ice. Now this ice field here is 215 square kilometers in total, and its largest size is 325 square kilometers. Now this ice field is here because the piece of land the ice field sits on is at a very high elevation, so it's very cold up there. Now there's also a lot of humid air which comes off our Pacific Ocean and travels east across Canada. It reaches this high elevation and begins to cool. And when this humid air cools, it condenses to form snow. So out on the ice field, we can see up to 30 meters of snow a year, and that snow just continues to pile up to produce ice. Now this glacier that we're on today, this is the second largest glacier coming off the Columbia. There's 6 glaciers in total. So this glacier here is about 5.5 kilometers long by 1 kilometer wide. So there is one larger glacier which is called Saskatchewan Glacier, and Saskatchewan Glacier is about 9 kilometers long by 2 kilometers wide. Now while you're out here today, you may notice that some of this ice has a bit of a blue looking tint to it. Now to explain why the ice is blue, I first have to explain to you why regular snow and ice are white. So regular snow and ice have tiny little bubbles of air in them. These little bubbles of air, they reflect the light and they reflect a white looking color. So this is why regular snow and ice looks white to us. Now this glacial ice is formed under extreme pressure. The pressure squeezes the air bubbles out of the ice so they're no longer there to reflect the light. So the light reflects straight off of this glacial ice, and because the ice is so dense, it reflects the lower end of the visible spectrum, which gives us that blue looking color. Now to our left hand side, we got a beautiful view here. We got 2 mountains. So we got the mountain which is furthest back is Mount Athabasca. There's a mountain which is further along about 10 o'clock. That's Mount Andromeda. Now if you take a look between these 2 mountains, you're going to see a large rectangular mass of ice. And that is the glacier. Now that glacier there is unofficially named, but we like to call it AA Glacier or Double A Glacier because of the mountains surrounding it. Now AA Glacier is an independent glacier. What this means is it's not being fed by an ice field. It just relies on snowfall to condense into ice to help maintain its size. Now there is one other glacier which I would like to point out to you today. This glacier is to our left hand side once again at our 10 o'clock as well. So this glacier is sitting in the middle of Mount Andromeda. It's called Andromeda Glacier. Now Andromeda Glacier is a very interesting glacier. It's called a cirque glacier. And cirque glaciers, they carve circular bowl shapes into the mountainside. So if you take a look at Mount Andromeda, you're going to notice that a big chunk of the mountain is missing in the middle. And that's because this glacier's been up there for thousands of years carving out that mountain. Now we're just arriving at our turnaround point here. This is the deepest part of the ice. This ice here is 1,000 feet or 300 meters thick. Can I get an ooh, ah? Excellent.